Hello, hello, hello. Quick mic check. I hope you guys can hear me. Give me some response, please, in the chat before we actually start with everything else. Let me type in chat quickly. Seems like Discord is sometimes a little bit weird. Okay, 1 second. I need to... Hello, hello, hello. Hello now. Something. Hello. Test 1, 2, 3. Can't hear me. Okay. So 1 second. Let me bring up some things here. What about now? Just a quick test. This is weird. Hey. Okay. Hello, can you hear me?
All right, you can hear me.
Yeah, can you hear me? Okay, seems like not. Let me leave the stage. Let me try to connect. There we go. Can you now hear me?
Yes, I can hear you.
Okay, perfect. There we go. Thanks. Okay, this is always such a hurdle to get Discord starting. It's weird. I need to actually start the town hall, then I need to disconnect and reconnect in order so that you guys can hear my voice. That's weird. I don't know why this is happening, but it is what it is. So nevertheless, thank you guys for all of you who are joining in, who are listening to today's town hall. We are having the town hall number 4, and we do have a couple of topics that we want to talk about today. First of all, thank you, Scott, for being here, for being on stage. It's perfect that you are here because one of the first topics that I want to talk with you about today is the recently, we can say, innovated Bitaxe Supra. It's something new that we want to definitely talk about. Afterwards, we also want to talk about a couple of changes that has happened to the recent Bitaxe version, aka the version 205. Then definitely we need to take on and talk a little bit about the solar tracking setup that we do have seen from our lovely community member CryptoIce. And if that is not enough, we also want to talk about the Bitaxe Hex because things are brewing, things are amazing, and we definitely want to hear more about it. But let's get started. Scott, thank you for being here. Let's get started and let's talking about the Bitaxe Supra. Maybe you want to tell us what this is.
Yes. Well, first of all, Clue, thank you for putting this town hall together. Number 4, this is pretty badass. This is a cool thing to do. We got like all sorts of people in the audience, so this is going to be cool. So Bitaxe Supra, it's the next version of the Bitaxe. We got Nebula Miner in the crowd. Nebula Miner is responsible for naming the Bitaxe Ultra, which is probably the best name we've had so far. He also did tons of work on the technical side of the Bitaxe Ultra, but he named the Bitaxe Ultra. So Nebula also named the Bitaxe Supra, and yeah, it's the next version. The highlight is that the Bitaxe Supra has the chip from the S21. It's the 1368. The S21, I mean, most people probably know what's up with that, but it's the latest and greatest Antminer from Bitmain, just released just started shipping a couple months ago. We got this thing working in record time, thanks to a lot of help from Ben, from Johnny, from Nebula, from JP. I don't think he's in the crowd, but JP helped out a bunch with this. And yeah, so it's working. The Supra's working. We have the first version. It's called 400. That's the version number, and everything's released. We have a branch of the ESP miner firmware that supports it. Actually, I think Johnny might have merged that into master. I got to check on that. But we got firmware support. We got hardware support. It's working. In fact, we have just about to be released is 401, which is there's actually wasn't really too many bugs. It's just kind of updating, taking everything from 205 and merging it with 400 to make 401. So now 401 and 205 are the same form factor, same size, everything's in the same place, and have all the same features, with the obvious difference of the main ASIC that's on there.
So basically, you could say the design of the Bitaxe, how it currently appears, is the same. The major difference is here the chiplet that we do use, or the ASIC especially.
Yeah, that's right. So 400, the first Bitaxe Supra, kind of was in the works for a while, and meanwhile, the Bitaxe Ultra kind of moved along and had a newer vision. So that's what 401 is the Ultra picking up what the Ultra had, 205. So 401, it's all up on GitHub in the Bitaxe repository. You can check it out if you're interested. It's going to be released soon. We kind of have an interesting problem now, is that sort of in the past on the Bitaxe repo, master has always been kind of the latest and greatest, but now we sort of have two main Bitaxes. There's the Bitaxe Ultra and the Bitaxe Supra. So I don't know if I need to make like another repository, or maybe just have a separate branch, just keep it on a separate branch so that we can have sort of these two different models being developed in parallel. Because the chip out of the S21, it's a little bit more efficient. It's sort of nominally 17.5 watts per terahash, whereas the
amazing.
Yeah, but you know the 1366 out of the XP was nominally, I think, 21.5. So it's a little bit better. It's not too much better. So you know, the other problem with the Supra chip is that no one's selling it. It's so new that none of the repair places are selling it. Actually, I take that back. I think there's a couple people, maybe Decentral, that are selling the chips, but the whole like industry of selling bare chips hasn't really sprung up yet. So basically, the only way to get those chips is to buy an S21 and unsolder all the chips. So it's a little bit tough to just kind of dive into the Supra right now. So I want to keep the Ultra going, so that, you know, if people want to jump in, they can do that. And the Ultra is still, you know, a pretty solid home miner.
So one of the major things, or major questions that I'm in particular interested in, is what is different about the BM1387? Like, that's the chip from the S21, if I'm not mistaken on the number. But what's one of the
1368 is the S21.
68? Okay, 1368. My bad.
And 1366 is the XP.
Yeah. So we had this issue with the Ultra one, that we do not have an integrated temperature sensor in the Bitaxe Ultra. We need to have like a separate temperature sensor as close as possible to the ASIC chip. What's about the ASIC chip from the S21? Does this have an integrated temperature sensor?
All signs point to yes. We've been doing a lot of careful looking at the way that the S21 works, and it does appear to have on-chip voltage sensor and temperature sensor, which I have not confirmed, but it doesn't look like the XP chip, the 1366 that we use in the Ultra. It doesn't look like that had it. So this is new for the S21 to have on-chip temperature and voltage sensing, which is pretty huge. We think we have a pretty good handle on how to actually utilize that feature and get those temperature and voltage readings back, but it's not implemented in the firmware yet. Mm-hmm. Just a little bit of hacking on the firmware to make that happen. But yeah, that's the idea, is we'll get actual on die temperature readings, which is way better than what we have on the Ultra, which is essentially an air temperature sensor that's just on the PCB, very close to the ASIC. And so there's like an offset, because we read the air temperature and we kind of have to just wing it to guess what the actual die temperature is. So That's a big benefit for the S21 chip.
That's quite cool. Like, and I think like the current stage of the Supra is more of currently just a hacking branch, you'd say, on GitHub. And I bet like as soon as the full one has been released, then you can actually call it like the first uh, in production product that could be manufactured, right? So currently
Yeah,
there's
yeah,
not the
that's right.
stage of it's being produced and people can buy it in 2 or 3 weeks. So we're currently not on this stage, but we're getting there, right?
Decentral is, sort of against my advisement, but they're free to do whatever they want. But they're taking pre-orders for the Supra, and they're going to start manufacturing them. Jonathan over there has got his guys stripping chips off of S21s to build this. Um, you know, the timeline is a little bit unclear. I talked with him a bunch about this and sort of what he can promise on the timeline because we're still working on it. Like we're still hacking on it. I wouldn't say it's ready for production. It's close. It's close. I mean, I've got one running on my desk right now. It's been running for over a week. No problems. But like I said, it's a new one, or like you said, it's a new version. We're still kind of working on it. There were some definite changes to the chip itself. The chip itself is bigger, has more pins. And if you go and look at the schematic for the Supra, there's like 4 pins on there that I just have question marks next to. So
So
that's
probably some temp
not,
sensors.
you don't really want to have a lot of just question marks in a schematic typically. So there's some unknowns. So dive into that one, at your own risk. But I will say unofficially, it's looking pretty good.
Yeah, probably something that we could investigate in one of our sniffing sessions. Maybe we actually need to design some sort of this idea of having a ASIC testing station, especially for the new S21 chips, where you just put on the ASIC and a heatsink on top of it and just test what the serials are doing. Maybe that would be.
Well, we've done a lot of serial analysis
Mm.
so far. Actually, a couple people, Checksum Zero and JP, got these early like pre-release S21s, and both of them were kind enough to send along a serial trace, logic analyzer capture of the serial lines. So this is like before anyone even got these things, they were doing that. So that gave us a head start, which was fantastic. So we have a pretty good idea of the serial communications. I would say maybe, I don't know, 80 to 85% complete on what's going on there. There's still some work to be done on changing the frequency, the hash frequency. Of course, there's still a little bit to be done on getting those temperature and voltage readings. And there's still, we can see registers being read and written. Nebula, if you want to dive in on this, I know you're busy, but there's definitely a couple registers that we don't have a full understanding of what's going on. So still work to be done there. Yeah.
But
Yeah, where was I
that's
going with
pretty
that?
cool. That's pretty cool. Like we are gonna have a S21 chip very soon in one of the newest Bitaxe versions. It's so amazing. By the way, while we're talking about new versions of the Bitaxe, some people have questions about the newest version, the version 205. And I do know, and most of the time I do refer to the people that most of those improvements are typically some changes to some ICs or sometimes just improvements for better manufacturing. But a couple of things are different to the 2.5 version. Do you have some thoughts on that one?
Yeah. So Ben did a lot of work on, because he's assembling a lot of these things, and he kind of comes to me with sort of design for manufacturer stuff, like things that he notices in the mass production of these. So it includes a lot of things that he's brought up, whether that's parts availability or what's a pain in the ass to solder or where we're seeing failures. So we get those incorporated. There was from our esteemed member, Mr. CryptoIce, there was a request to actually rotate the heatsink 90 degrees so that the fins kind of point top to bottom. think he wants to get his coolant flowing through there. So we finally got the ability. We added 2 more holes for the heatsink mounting, so you can just rotate that 90 degrees. That was kind of a slippery slope. It was like, oh yeah, we can totally do that, no problem. And then it was like, oh my gosh, I got to like move the USB port to the other side of the board, which we did. But yeah, so it includes a number of DFM improvements. It includes the ability to rotate the heatsink. There's the way that the display mounts is slightly different. Hopefully, a little bit easier to manufacture. Hopefully, produces a more better looking result. Those stupid barrel connectors, man, they keep going out of stock. It's insane. Like we want to have an SMD barrel connector for ease of manufacture, but I swear they keep going out of stock. It's wild. So the 205 has yet again a different barrel connector part number on it, and of course, between these different barrel connector part numbers, the footprint is different. So it requires that whole like corner of the board layout to change. So we got a new, hopefully, knock on wood, this part will stay in stock for more than a week. And I think that's it. Ben, do you remember anything else? Changes on the 205? Again, this is sort of a service update. I can see Duncan's typing. It's got the new. Okay, this is cool. Yes. It's got it's called the Bitaxe accessory port. And the Bitaxe accessory port is, it's like half a dozen holes along the top of the board that forms a pin header. And the idea is that this is going to be a port that connects to the ESP32 that it's sort of, its pin configuration and its position and things are not changing. So people like Duncan, who build the amazing BitHalo, can have a more official first-class way of interfacing with the processor. For those who don't know, the BitHalo is kind of the first real Bitaxe accessory, and it's this like super cool thing that Duncan made. It's a ring of LEDs that go behind the Bitaxe, and he's got it set so that it flashes when you submit a share. And then, of course, when you find a block, it just goes like ape shit and blinks all over the place. It looks super fantastic. He hacked in a bunch of like pogo pin test points on the backside, which is, it's fine. It totally works, but that's not exactly what they're intended for. So it's like, all right, well, let's make a port that people can hack on. And I think that the next rev of the BitHalo will support that. And then we have this kind of amazing initiative going on to do solar mining. And my hope is that the Bitaxe accessory port can help with some of the solar initiatives, whether that's controlling a solar maximum power point tracker or a actual like physical position sun tracking for your solar panels, or interfacing with basically anything else that you want to interface. And the cool thing about the ESP32 is that any of its GPIO pins can be any of the digital peripherals, so that on this accessory port, you can have a UART serial, you can have SPI, I2C. There's also power and ground, and you can hack on it and have some confidence that it's going to be there in that position for future revisions.
That's pretty amazing. Really, I've seen a couple of different designs from manufacturers that are trying to add on some different things to the Bitaxe. For example, I'm not sure what company or what manufacturer was doing this, but I saw one Bitaxe design where they tried to get rid of the I2C display and instead like put on an SPI display to have like a bit better visual of what's going on, like high quality pictures being displayed on this. So that could also.
Well, we got Bitmaker in the audience here. Bitmaker is the famous creator and builder of the Nerd Miner, and he has been working on the Nerd Axe, which has got that really cool display that the Nerd Miner has on
So
the
maybe
Bitaxe.
we try to get him on stage and talk about it.
He says, "Guys, I'm almost finishing it, so
that's
any
amazing.
day
So
now,
let's
Nerd
get him on
Axe. That's
stage.
going to be
Maybe
cool."
He's interested in telling us a little bit about it. Let's see. Yeah, there we go. Hey, Bitmaker. Lovely to have you here.
Hi guys, hello.
Yeah, we can hear you.
Yeah.
Oh, fine. Thank you very much for letting me be here. Just is fantastic, the Redux project, and yes, I'm trying to finish the interface, a similar interface that was made in the Node miners, just to be introduced inside the Bitaxe project using LBVL and some similar screens that were made on the Bitaxe, letting you hack on any kind of Bitaxe board and adding an SPI display and then put that kind of screens on the Bitaxe.
So
That's the final idea.
That's pretty
BitMaker
cool.
is like a master of these displays. I think that was one of your like big improvements on the like the Han Solo miner, right? Is you got this display that like looks badass, right?
Right, exactly. The idea is if the starting point is using the TTGO T display, that's using the same IC, that's the S3 ESP S3, and then my intention was to let the Bitaxe to be agnostic from the display interface. So like the nerd miner is, you can to be able to use any kind of display to be shown on the interface of the VDAX using the ESP of its board. And that could be interesting. I don't know if it's possible or not, but to let more processors, like any kind of ESP, to be working with the same ESP miner. So at the end, you could control the main ASIC and manufacture any kind of miner. No, so letting the makers to make his own miner as they want.
That's pretty insane. I really love the idea, especially like as you said, Scott, the display and the improvement that you did BitMaker on the Node Miner version. It's pretty insane. I still love to look at it just for the sake of having such a nice display here on the desk and running and watching what's going on the blockchain, what block height we are having, and just having the option or the opportunity soon with you to have like a better display on the BitX would be quite insane, especially with the idea that you're presenting to have like this main device that is controlling all the other ones would be so lovely. I can't wait to see it in action.
I will show you some of the pictures just in the chat, and I hope because I was working last week on this and also the revision of the board. I will push it to the branch of the Nerdax that's on the Discord GitHub, and you will see there obviously the next week. I assume, but I will show you some of the pictures because it's interesting that if you see something that you would like to add, that's not now a good moment. And obviously, with this audience here is a good moment to let you to say something if you would like to add it to that displays.
It's lovely. So, guys, leave some love for him. Follow him in on Twitter or anywhere else, and leave a comment if you want to add something on his display. It's amazing.
Okay, I will show you just now in the chat, and let me just in 5 minutes we can talk about anything more, and you will see there and give me some clues about if it's okay for you to put it there.
Yeah, sure. Just put something in the chat. That's lovely. Let's have the audience a little bit of pictures and seeing what you're working on, what you're doing. That is definitely lovely. Can't wait to see this thing really in action. As well, I also saw this thing like as I said, I'm aware of the display that you're trying to put on, but also I've seen the idea from you that you just use this TTGO display. I think you mentioned it that you want to use this TTGO display just to plug it onto the PCB of the BitX so that this one is actually controlling everything.
The the Nerd Miner and the TTGO S3 display, they both have the same ESP32 S3 that we use on the Bitaxe. So it wouldn't be a stretch to have that processor control the Bitaxe.
Exactly. In my own branch of the ESP miner, I just adapted some of the pip panel of the Bitaxe. And as Scott told you, all the GPOs are ultra configurable, so you can move any SPI pin to do to any kind of the JPIOs. And the idea to have a connector that let you just plug your pins, it's more for the maker part, but it's interesting on that idea to let people just use any kind of controller board and then just have the ASIC, like being the ESP board, the controller, the control board, and then the ASIC board, the whole where the ASICs are. No?
Yeah, I mean the idea is really insane. Like it's a good idea, and definitely can't wait to see this. Like this is what this whole community is about: just improving, changing, and tinkering on new design ideas and new ideas overall. And I think that's also a good stretch to one of our next topics. And we do have another speaker here on stage, Meg Pfeiffer. It's lovely to have you here. Thank you for being here. The reason why we are having you here is because we want to talk a little bit about one of the biggest projects, one of the projects that most people are interested in to see in the next couple of months on their desk, hopefully at home, and that's the Bitaxe Hex. Meg Pfeiffer, do you want to tell us a little bit more about what's going on with the Bitaxe Hex? What's the current stage of the process and what's going on? Because in one of the last town halls, we talked about a couple of things. We talked about the issue that's going on with the PSU, and I think you have managed to solve one or another issue there. So let's see what has changed.
Yeah, hi there. Thanks for having me. Just for those who don't know, in English, the letters PH make the F sound, so I go by MacFighter.
Oh yeah, sorry, that's my bad.
No problem. So yeah, we've been making some good progress on the Hex. On the latest revision of the PCB, I built up just the power supply section, and I was able to validate the power supply. We got it. I hooked it up to an external load, and I was able to get up to 25 amps out of the power supply, which was really, really good. It's performing very well. So after updating the firmware in the ESP miner to configure the power supply, I felt like it was finally time to power up the fully assembled board that Ben had built. So I got it all powered up and running. And initially there was no hashing activity. And late one night, between Scott and Johnny Nine poking at it, eventually we got it working, and it's actually hashing now. We have it running. It's getting consistently over two terahash, and I think it can be pushed faster than that. There's a few obstacles right now that are currently preventing that. The biggest one seems to be there's some serial communication errors that are happening, and we have not nailed those down to the root cause yet. It could be a software error dealing with a checksum, or it could be a hardware error, some signal integrity on the serial communication lines. But we're still poking around and trying to nail that one down. And I think once we solve that, the serial communication error is probably throttling back the hash rate just a little bit, clogging up the pipeline. Once we clear that up, we should be able to go faster. I'm thinking maybe at least 2.5 terahash, maybe more. I don't know. We'll have to wait and see how it goes. So that seems to be running pretty well. There's a number of items in the firmware that still need to be updated. The fan driver does not work yet. I'm still working on that. There's some cleanup in the power supply driver configuration that I need to finish. The GUI update still needs to be performed. There's a number of items on the Hex that don't exist on the Ultra that need to be displayed in the GUI. There's multiple temperature sensors that need to be added. a different power supply configuration, gives us some different numbers that we need to customize the GUI for the Hex. But it's all being worked on in ESP in a branch called Hex V302. So we're moving right along. It's looking pretty good.
That's really pretty amazing. And just to give all our listeners a little bit of a start or a visual thinking about how big is the Hex actually? Like, what would you compare it to?
Well, the actual PCB is maybe I don't know, maybe close to twice the size of the Ultra, roughly. But the ASICs generate, since there's 6 of them, there's a lot more heat being generated, so we need a big heat sink to go on top of that. And then we selected this aluminum enclosure that's big enough to enclose the board and the heat sink, and put an 80 millimeter fan on the outside. So the whole unit is significantly larger than a Bitaxe. But Ben had this great idea of turning a Bitaxe Hex on its side, upside down, and sliding it into the top of the enclosure. You can actually fit 2 of these. Oh, he posted a picture. You can see you can actually fit 2 of these inside. So the cooling seems to be running very well inside this little box. So I suspect Ben's idea of putting them back to back, upside down, facing each other, is probably going to work out.
That's so amazing. And for all the listeners that are listening to this later on, I'm sorry, but we do have this channel here in Townhall that's a text channel there. You can join in and just look at those pictures of the Bitaxe Hex, and probably also in the Bitaxe Hex Discord channel itself. There are a couple of those pictures of it. So that's definitely lovely to see this, and especially this improvement that it is finally getting into something, that it is finally starting hashing. And as you said, obviously there are a couple of tweaks that needs to be done. But what are those next steps that are on the bucket list to do?
So there's a number of firmware items that I mentioned that need to be finished up. There's probably some tweaks we can make to the power supply just to clean it up. I'm considering adding some more capacitors to the output to make sure that there's no ripple. The heatsink mount is a little bit awkward, and we don't have an easy solution for that. Right now, you have to take this heatsink and drill some holes in a very precise location, and then tap the holes with a tap, and then use the screws from the back of the board to hold the heatsink against the board. And if you tighten the screws down too hard, it will cause the board to warp and curve, and you may not get very good thermal connection to the heatsink. So we've been discussing this, and I think we're going to add some more heatsink mounting holes in between the ASICs so that you can get the right amount of tension without warping the board to hold them against the against the ASICs. So that's one modification that we're thinking about. And then a little further down the road, we've discussed the possibility of adding a new display similar to the Nerdax. And we're talking about ways to do that. We haven't gotten very far with that process yet.
But that's pretty cool. That's really amazing. And by the way, while I'm looking at those pictures, this heatsink is kind of massive. So the main goal is to actually have this device as being air cooled, I guess. Like, obviously, some people are maybe thinking about adding water cooling to this, especially with 6 ASICs. This could be also viable or suitable, especially for this type of temperature that we're getting, or this heat that we're getting out of 6 ASICs instead of just one. What's your guess on this? Like, would you think it would makes more sense to go with water cooling solutions, or is air cooling the way to go for the first implementation?
Well, for the majority of people, obviously, it's a lot easier to do air cooling. And as people start building these up, it's going to be a lot easier for them to air cool it. I know that there's people who are huge fans of the water cooling, and especially immersion. I think you'll be able to benefit a lot from immersion cooling. Crank up the hash rate. One thing that Scott and I have noticed is so far on the current design, we tried cranking up the voltage and the hash frequency a little bit, and it did not seem to increase the hash rate by very much, if at all. So there's lots of experimentation that needs to be done here. Once we get these into people's hands, you'll be able to play around with the voltage and frequency and see what you can actually make it do.
I think there's a lot of room to improvements in the firmware, right? Like MacFighter was saying, I tried turning up the hash frequency a bit, and it actually made the hash rate worse. But I don't think that's a hardware limitation. Certainly not a limitation of the ASIC or the Bitaxe Hex. We might actually just not be changing the hash frequency correctly. So definitely a bunch of work to be done on this. A lot on firmware. I mean, MacFighter's been doing an excellent job of the power supply design for this thing, which is, it's non-trivial, right? This is a pretty complicated power supply. We're on the third power supply for the Hex now, or power, voltage regulator. So it's a tricky thing to get right, and it's the power supply section is actually working really, really well. That's been nice. We also, this has, the design of the Hex has it has 3 voltage domains with 2 chips in each, and so we have this kind of difficult problem of doing voltage level conversion as the data lines and clock pass over these voltage domains. It's a total brain fuck actually to think about from an EE point of view, like how those signals work going across the voltage domain. MacFighter's done an amazing job coming up with a level shifter design for that, which it seems to be working. I mean, I guess we have a little bit of work to do to make sure the integrity of the serial lines are working, but that's one of the big hurdles for doing a multi-chip design, was figuring out how to handle voltage domains. So, I mean, I'm super impressed with how this has come along so far. It's been really cool. It was really, really exciting getting it working this week. So yeah, shout out to MacFighter for doing an excellent job there. And of course, Ben made these boards so that we didn't have to put it together, because this thing is a beast. There are so many parts on this. I tried hand assembling a previous revision, and it basically took me 2 days. And I got a lot of experience doing these, so it was nice to have those put together. And then shout out to Johnny too, also for getting that firmware. It was kind of cool. We were late night hacking on it, and I was like, oh man, this thing's turning on. We just need some firmware now to bring up 6 chips. And Johnny was like, okay, yeah, I'll add it. Here you go, try this. So that was exciting.
That's so damn cool, really. I can't see to actually have this device up in stock from some manufacturers, and actually shipping this to all the people, that we can get more and more people onboarded to mining at home without the need of actually buying some proprietary hardware or firmware from other manufacturers. That's so insane. It's just a big step into the right direction of what this community is standing for. That's absolutely amazing. By the way,
so
yeah, go ahead.
Let me throw out a quick note here. The Hex assembly is slightly more advanced in complexity from the Ultra. And so I know there's lots of people who are going to be really excited and want to dive right in and build one of these. And if you have experience building these kind of things, then that's great. You'll probably be fine. But if you're a beginner and you've never built one of these, I would suggest you start with a regular Bitaxe Ultra and learn the ropes. Get good at soldering these things up before you attempt to build a Hex, because the complexity is just a little bit more advanced.
Oh yeah, definitely.
Yeah, it's probably about 6 times more complex.
I mean, if you guys really want to get into this and you never have soldered in your life before, just take a look on those live streams that I did about trying to assemble a Bitaxe. It was hell of a headache for me, and some of those still don't work, but it is what it is. It's difficult, it's not easy, and I can definitely agree on this. It will be way more complex. I've taken a look on those keycut designs, and I was impressed by the amount of capacitors just on the downside of it. This was hilarious. So, but nevertheless, you got me thinking into one thing while we're talking about firmware changes and stuff, especially for the Hex. Things are going exponentially higher when it comes to firmware stuff. And so one thing that came up in the community was the ask or the request for actually being able to change frequencies on the go without the need of actually restarting the device. This is, I'd say, a regular questions that does not fit into a Ultra or Hex or Supra topic. It's more of a general question for all future firmware updates, I'd say. So do we have any thoughts on what's going on this end?
So I'm also very interested in this as well. I think that's going to be really important for some of these solar projects, is the ability to change the hash frequency quickly and effectively. And you certainly don't want to restart because that just takes extra time. So we've been looking at it. There's a UI reason why it doesn't work, because the UI currently needs to write a lot of the settings to the non-volatile memory, and it's just a lot easier to restart when you do that and then just load them again from the non-volatile memory. There's also sort of an interesting concept of how you change the hash frequency on these ASICs. So obviously there's no data sheet for any of these, so we're kind of like learning by trial and error, but it really seems like the PLLs, that's a phase lock loop, and essentially it's a clock frequency changer. So for example, there's a 25 megahertz oscillator on the board, and that provides a 25 megahertz clock rate, sort of clock signal into the chip. It's the PLL's job then to take that clock frequency and change it to whatever the board needs, right? Like maybe we want to have a 500 megahertz hash frequency. So it needs to change that 25 megahertz signal into a 500 megahertz signal. Maybe we want to have a 1 megabaud serial clock speed. So that needs to go down from 25 megahertz to 1 megahertz. And so it's the PLL's job to do these clock frequency transformations. And it turns out you can't actually just say like, oh, hey, here's the new clock frequency that I want, go. They need to be babied a little bit. All the examples that we've seen, they ramp the PLL's frequency up and down in sort of discrete steps, going slowly up and slowly down. If you just sort of give it its new value, say you're at a hash frequency of 400 megahertz and you want to be go all out at 600 megahertz, and you just do that all in one step, it won't work. It'll essentially it'll freak out and not work. So you need to baby it. We're kind of figuring out what is the right way to baby it, what is the right sort of delay between steps, what's the appropriate step size. Like if you go and download Luxor firmware for your XP and you want to change the frequency, now they have 330 chips to change the frequency of, but it'll take minutes to actually change the frequency. It does it really slow. And Luxor is, I think, the only one who can actually change the frequency on the fly. Like if you have brains, they'll just restart and take a long time. I think it takes also a minute or two for it to come up. So there's some challenges there. The challenges actually it's more difficult to change the PLL the more chips you have. So we'll have to be more careful with the Hex to change the frequency like that. But there have been some signs that we can do it fast. that we can change frequencies fast with a very small delay. And we're working on getting that in there. I think that would be, I'm totally on board. I want it too. If anyone wants to help out with this and try and test some things and write some firmware to try out different ideas, that would definitely be much appreciated. But yeah, I think we'll get there. And I think it's essential for these solar powered projects. I know Agent P and I've been talking about this a lot, but there's really some really exciting things that you can do with efficiently mining on solar if you can change the hash frequency quickly and obviously do it without crashing the thing.
No, yeah,
so that was a long answer to your question.
No, but that's a good answer to the question, because it's really interesting and it really needs to be discovered. Like, as you mentioned, only Luxorus is currently the one and only that we know of who is actually be capable of changing on the fly without the restart. As I said, even the original Antminer firmware is just restarting the whole machine instead of just doing it on the fly. So that's definitely an interesting topic to dive into.
Well, Antminers don't even change. Well, they have like a low power mode and a normal mode. So they basically just change between two frequencies. And I think they restart. They restart for anything. Like you change the stratum address and it restarts. I think that is, as we've
the most
also
way,
found, that is the
probably.
easiest and quickest way to do it.
So one interesting question, and making a quick cut here, is that we got in chat from Polar91. He was asking, it won't be possible to solder those ASICs one by one and test it after each one. So running it with less than 6 chips won't work or even damage it, right? I'd say no, because I do know the QX, for example, from our lovely member here in the Discord community, from Thomas. He designed the QX, and it is definitely possible to run a design with multiple chips that are chained in series with less than all those chips on it. But I'm not sure about the Bitaxe Hex, so I'm not sure if it is possible to run a Bitaxe Hex with less than 6 chips. But for the QX, for example, it's definitely possible. So you can solder the first one, check if everything is correct, then go to the next ASIC, check if everything is correct, and make progress on the way. So I'm not sure how this is for the Hex, but for the QX, it definitely works.
Yeah, I want to give a shout out to the PyAx and the QX creator, PMaxUW. He was the first one to get multiple chips working, at least here in the OSMU community, and that's no small task. He did an amazing job with that, and I've watched your videos, Wanklu, about running or assembling and running the QX. The thing looks amazing. It's super cool that you can. Even though it's designed for 4 chips, you can run 1. That's amazing. That's cool that it works. And everyone should definitely check out that project. That was cool. I feel like you got that working a while ago. So that's a very awesome achievement. There's a slight difference in the way that the QX is powered from the Bitaxe Hex. So, and maybe he can correct me if I'm wrong here, but my understanding of it is that the QX has all of the chips powered in parallel, meaning that the 1.2 volts or so, each chip is powered directly from 1.2 volts.
Yeah, that's
and they're
correct.
all
It's
powered
voltage
in
domain.
parallel. Yeah, so they're all in one voltage domain. Yeah, that's a good way to put it. And I think that's what allows you to power the chips up one at a time and test your soldering. The Bitaxe Hex takes a different approach. The Bitaxe Hex takes the approach that is used on the Antminer hash boards, where we have multiple voltage domains, and those are connected in series, meaning that each voltage domain is 1.2 volts, but they're sort of connected together end to end, meaning that you can power the 3 1.2 volt voltage domains with 3.6 volts, and it just divides that 3.6 volts by 3 to get 1.2 amongst the whole chain, they call it. There's some advantages there. As you get bigger, more and more chips, it makes the power supply section more manageable, because you don't have to have extremely high currents. One of the things about having multiple chips powered in parallel is that while the voltage doesn't add up, the current does. So every new chip that you add in parallel, you just need that much more current. And it can be tough to do low voltage power supplies at very high current. It requires big, thick traces on the board and a bunch of concessions to deal with that. So the alternative is to keep the current the same, but raise the voltage by connecting them together in series. And so that's what's going on in the Hex. It's perhaps more extensible into more and more chips, but then you do have this problem of it's like the old school Christmas lights, where if one of them in the chain goes out, the whole chain is done. You can't practically run this thing with any of the chips missing, and if one of them isn't working, then the whole thing goes out. We have seen that it's not like if one of them goes out, the whole chain is destroyed. I do know from experience that if one of them is not working, it just doesn't work. It's not like the whole thing is destroyed. So,
I mean, that's
and then of course there's the issue I talked about earlier of the challenge of getting the data to cross the voltage domains, which is a level shifting exercise.
That's actually a good thing. So one thing that also comes up to my mind is like, how do you then clarify what which ASIC is not working? How is the process on this end? Like with the QX, for example, my understanding from the QX, it's pretty clear, like the chain, and you can actually figure out if the first you sorted is correct and it's working, then you test the second one and out of a sudden it does no longer work, then you definitely know, okay, the second ASIC you mis-sorted or anything else. But how does this actually work on the Bitaxe Hex, for example?
Man, I wish we had Sir Vapes-a-lot in the chat here. He's a professional Antminer repairman, and so he deals with this question all the time, because this is a very common occurrence with Antminers. I don't know how many, like zillions of these he fixes a day, but the main strategy is there's a firmware, there's a command that you can send to each chip, and you can say, hey, respond. Send me back essentially the part number. And so, in this case, it'll send back 1366 in hex. And you can broadcast that command to the whole chain and then look for how many responses you get. So if you get less than 6, you have a problem. And so this is exactly what happened to us the other night, or it happened to me, is I ran it and I got, only 2 responses. There's supposed to be 6. So what's going on? So you can pretty easily take your multimeter and measure the voltage across each voltage domain, and you can see which ones aren't working because they have a I think they have a lower voltage across them, and so you can see that they're not doing any work, and that can help you diagnose what's going on. Help you narrow in on which voltage domain the chips are in that have a problem. As far as figuring out which chip in the voltage domain specifically has the problem, you can look at the the serial, the responses coming back, and sort of how far it makes it. You can look at the I/O voltages and see how far they make it across the domain. Also, on the Hex, we only have 2 chips in the domain, so it's not too hard to narrow in on where the problem is there. But yeah, it's kind of a manual debugging experience with a multimeter. I've heard about some interesting designs where you can use big old MOSFETs to try and bridge across chips that aren't working to sort of get the whole system back online. I think that's an interesting idea. It adds quite a bit of complexity, and I mean, to be honest, I'm of the persuasion that if your machine has less than the correct number of chips responding, then you've got a problem and you need to fix it.
I think that's very well explained. on how to narrow the issue down. So yeah, definitely we do see there's a ton of knowledge needed in this task, especially of when you want to try to hand solder this. I probably will never do this, but yeah, for other people who want to do this, as you, for example, it takes quite a time and definitely quite some knowledge to do so. But I think
I just wanted to say, like, with sort of great power comes the great responsibility. So these boards are getting more, with the Hex, are getting more and more complicated, and it gets to be a more and more complex system. So, I mean, that's one of the coolest things about the Bitaxe, right? Is it's honing in on kind of as simple as this can possibly get. I realize we got 402 components, which is a little bit hard, but we're working on that. I think the Nerd Axe will help with that, with some more plug and play type stuff. But yeah, I mean, to get more hash rate, just it takes more components to the system and more things that can go wrong. So it does kind of push it out of the hobbyist assembly realm and more into the just buy one realm, which is kind of too bad, but it's also cool. I mean, it's going to be all open source, right? If you do want to dig into it, at least you have that option.
Oh yeah, definitely. I mean, it's always about this open source mindset that we do fulfill here with everything. Let's keep going here, and I think just having the possibility of doing so, and even if you just, I'd say, like, even if you just download the Gerber files and manufacture your PCB from one of those big PCB manufacturers, and then maybe you add in the assembly process as well. Maybe it's a little bit expensive, but at the end you can say you tried your best to actually build this on your own, and you do not trust any manufacturer. You just trust the process of open source. I think that's the biggest thing that we do fulfill here, and that's really amazing. So, thank you, Max Cypher, for being here on stage and telling us about the news on the Bitaxe Hex and what's brewing with it. That's really amazing. I'm really glad that finally those pieces that you do have are working. It's really amazing. And now, for going a little bit into the end of today's town hall, I want to dive into one of our last topics. We do have our lovely member CryptoIce here up on stage. Hey there. I want to talk with you a little bit about your solar tracking thingy. We have talked about solar and solar adding to the Bitaxe, and as far as I do know, the solar idea has been on the Bitaxe from the very beginning. Like, Scott always wanted to invent the Bitaxe with some sort of a solar device on it, so that you are going to be able to just run it as long as you do have solar power. And you came up with something that you want to share with us. So let us
Well,
hear
good
what you
evening,
have.
everyone. Well, I've been posting updates as I go along, but it's just basically a solar tracker with a Bitaxe. I started off with just a solar panel, put it in the garden, and 20 minutes later, I was like, oh, where's the sun gone? It was around the corner. So this gave me an idea just to mess around, and now I've ended up down a rabbit hole. What is it to say? It's just an alien contraption at the moment. I'm in the process of putting the Bitaxe parts on the frame. A lot of plastic. But the idea is to keep it under $100, and if it works and it stays upright and doesn't fall over, yeah, I'll show the files for everybody, and you guys can put your printers to work.
Have you already managed to get some sort of a GitHub repository for everything that you do?
No, I'm not embarrassing myself yet. I'm printing experimental parts 3 times a day, so no. I like when I put it outside and it does 1 day of solar mining, then I'll say, okay, here's the files, and I start experimenting. I know it works.
So one of the biggest issues one of the biggest issues with using solar is, in particular, to have a bridge between those times where the sun is not shining or where a cloud is moving over your solar panel. So if I'm not mistaken, you do use a small battery just to power over those periods of time where you do not have enough solar power.
Yeah, this is a big debate we have. The final destination is, as Scott said, to master the art of being able to just use what you have, and that's it. Directly solar to, as best as we can, solar to Bitaxe, with as least components in the middle as possible. But currently we have software limitations. We also have Ohm's law to deal with, and we need some sort of a buffer. Now, the other question is there's multiple ways of a buffer. As in buffer, I mean something in between for the Bitaxe to maintain a stable power source and a renewable energy source, which is unstable in nature, be it sun, wind, anything. So in my case, I'm using a little battery. It's a little 12-volt, 6, yeah, I think it's 6 ampere hours. I don't know, it costs like $20. So at the moment, I've spent under $100. I mean, forget the plastic, the experimental parts of trying to put the frame together, but well, after I'm done, it should be one reel of plastic max and $20 for a battery. And there was $40 for the kit, which had a charger, a panel, a couple of cables. That's it. And then a Bitaxe.
How are you running the process of actually moving your solar tracking device? So tell us a little bit more about the solar tracking.
So the solar tracking device has an Arduino Nano as the core. There is the buck converter. Okay, so I'm using the buck converter to power the Bitaxe, 12 to 5 volts. Okay. That also has a cheeky output of 5 volts that powers the Nano. I mean, I'm going to have to make an electrical schematic because there is a little bit involved on the control side of things. But in a nutshell, you've got a power source, a main power source of the battery, and then feeds a buck converter. And then it outputs 5 volts to the Nano. The Nano controls 2 drivers currently, 2 different types of drivers, one for the big stepper motor, one for the small one, horizontal and vertical. And there's also 4 LDRs. LDRs are basically light resistors. They adjust their resistance based on how much light they get. And there's this little X contraption that I made. You can see on the top, but it takes the shade. So whichever one gets more sunlight, the tracker sends a command in a nutshell to turn towards the midpoint. That's the theory anyway. And then the panel faces the sun. The panel's outputting maximum 18 volts, which feed into a little charger that outputs a LiPo current charge profile to the little 12-volt battery, and then directly from the battery an output to the buck converter that powers the servo mechanism, or let's say the control mechanism for the tracker, plus the Bitaxe.
That's pretty cool. And
that's it, pretty much.
What about if the battery runs out of power? What happens then? Does it just shut off, or do you have any sort of battery
it should
protection?
turn itself off.
Right.
It would just turn itself off. I mean, if it reaches, I mean, it probably drain the battery quite low. But if she's not providing enough power, the Bitaxe will brown out eventually.
All right. So in the future, there might be the idea of adding some sort of charge protection or anything else there.
So at the moment, I don't have. I'm trying to not touch. I haven't. I mean, I might get Duncan to have his magic fingers on this because I haven't messed around on the level of actually tapping into the firmware or talking to the Bitaxe. So the Bitaxe is still independent. It's just the same way you'd find an air-cooled Bitaxe. The only difference to me is instead of a bar plug, you've got an alternative 5-volt supply. That's it. Mm-hmm. As soon as that 5-volt supply gets power, the Bitaxe is back to normality, whatever would be on your desk.
That's pretty cool. Have you actually run this multiple days in your garden or anything?
No, not yet. No. We're still at development crisis. I mean, we've just overcome the arm issue, having an extended arm for the panel, because I want the panel to have free, complete movement from east to west, plus 20, 30 degrees. It's not going to be 360, but in a nice 200 degrees. So there's allowance in the cabling for that. And then the vertical will go completely flat on the top and 90 degrees facing to the horizon. which I doubt you will ever see if there's buildings and stuff. But that's the plan. I'm planning to put some end switches, both on the vertical and the horizon as well, because I don't want it to rip itself apart if it gets too far out of sync. Plus, I've written a few, or I've stole a few lines of code to give credit where it's deserved, copy paste, from one of the kill switches, or the end switches, the one facing the sunset. So as soon as that's touched, it will reset the head facing east, waiting for sunrise. So it's actually pointing in the right direction instead of the back of it. And the last thing that I want to mention was, no, that's all that's in my mind, right?
I mean, that's pretty cool. That's really interesting. I mean, obviously, as you mentioned, the last thing you said was about when the sun rises, you want to have it in a certain position. So this definitely is different depending on where you are on this planet Earth, obviously. So
well, to get around that, I have a plan at the back. So basically, the way I've designed it, there's going to be imagine it in two parts. So you've got the top part, which is solar panel, horizontal, vertical axis, and that's hanging the battery and the power controller.
Mm-hmm.
And then underneath the bearing, the part that's stationary on the ground, you have the compartment that has the controls for all the arms and all the spinning and tracking. And then below it will be the Bitaxe, and they're permanently positioned. Now the goal here is on the permanent part of the base, there's going to be one side of it that I found these little button compasses on Amazon. They're like, I don't know, $3 for 20 of them. They're like, I don't know, 20 millimeter buttons. And I was going to 3D print a specific area of the frame that's supposed to always point north, which is the part that doesn't have any sun. So you'd put it in your garden and you'd spin the whole contraption looking at the compass to make sure your compass north faces the arrow north on the frame. So then you know that part of the frame's facing north. And then you just put it down. And then the whole contraption would be tracking east, west, and up and down.
Oh, that's pretty genius.
So you don't have any... Yeah. Because
don't...
you want the button to always be in that orientation, because the tracker will point east, west, and then up and down.
Oh, that's lovely. It's
if I don't put that in... Yeah. Well, it's not a fix. The end stops will hit in before you reach your full west. You know what I mean?
Yeah.
Or your full east, if you didn't orientate the frame properly. So to then figure out how to do that, I thought I'd stick a little button compass on. The ones you get on the keyring, that kind of thing, they're tiny.
That's pretty cool. By the way, I missed today to ask for questions or anything else from the audience. So we're kind of getting into the end of today's town hall session. But if anybody of you still has any questions or anything else, just feel free to ask in the chat. And yeah, otherwise we will keep chatting a little bit here and bring this to an end in the next 5 to 10 minutes, I bet. So anything else you guys want to chat about?
I was thinking while Scott was talking and the guys were talking about the hex, maybe make this a bit beefier to actually fit a hex underneath, because I think we can muster 55 watts out of a small solar panel, or at least double these up.
It'll provide a nice, boat anchor to keep this thing from moving around in the wind.
I actually try to balance having the battery behind the panel, so it's always spinning opposite to the panel, if that makes sense.
Nice. Counterweight.
Yeah, problem is these new batteries are very light. A lot lighter than I expected.
I do get a message just right in here, guys. I need to announce something. So for all those listeners or people that are currently in the audience, Citadel version 0.3.4 has been released, meaning I was successful with implementing PublicPool for Citadel, and it will be available tomorrow in the App Store on Citadel. So you can run your own PublicPool on Citadel from tomorrow on.
Oh, exciting.
You just need to update your Citadel version. It's pretty cool. So yeah, PublicPool on Citadel is done, so Raspberry Blitz is the next one, I bet.
Exactly.
Amazing. So, if we do not have any other topics or questions or anything else, then I think
We're going to have a public pool update.
Oh yeah, sorry, I totally missed this. Maybe we should bring Ben on stage because we do have definitely some changes on public pool here. I totally missed this. I'm sorry. Yeah. Hey Ben.
Hey, so yeah, we got some new changes, mostly on the Postgres branch. That's going to be myself, and I don't know if anyone else is using it. But today I'm working on backporting that to the SQLite version as well, or at least some of it, not all of it. Just because not everything's cross-compatible between the two databases, but we've had some pretty good improvements on performance. So we should see a lot better uptime. And I also tweaked the my Bitcoin node to handle the RPC connections better because some of the issues that was causing server restarts was the node was just running out of connections. So got some good backend stuff done. And of course we have the new high scores page. So that will show all-time high scores, best shares by any miner. And right now, the column's unknown. But as we get new scores, they'll update to whatever device they used. So if it's a Bitaxe, it'll show Bitaxe, NerdMiner, whatever it is. It'd be cool to see a NerdMiner up there. But yeah, and we have some other cool stuff coming down the pipe. It's currently in the works, which I'll have to talk about later. But this is not the end of the public pool, so there's more stuff coming.
Real quick, so you're talking about Postgres and SQLite, I think. What's sort of the reason and what's going to happen with the sort of change to Postgres? Why are you doing that?
Mostly for performance reasons. I was talking to K1 and we were addressing some issues I was having. One of the design considerations I hadn't taken in with Postgres was the way they do locking. So like in Microsoft SQL, you can change the isolation level to read essentially like rows that are being updated, but that is not the case in Postgres. So you can't do dirty reads. So if you want to like read the whole table accurately, or even get just like an overview of the whole table, you have to lock the whole table. So I changed some indexes, I changed some primary keys, and I changed some application logic to make sure that the rows are not locked when we need to query, like the reports, like the user agents and the like the hash rate graphs and stuff like that. So I mean, overall, it's going to provide a lot more accurate reporting. You may have noticed, like sometimes when we went to public pool, it would show like like a quarter of the actual like miners that were mining, and like you'd refresh and then it would show all of them again. And that was just because of the read isolation levels. So yeah, it's kind of a more technical reason, but I mean, there really is not a whole lot of difference. Just indexes and keys and making the whole thing perform better.
Yeah, and also another thing, it maybe was not really clear, but I think I made an announcement about this. We do have also a new API endpoint for the public pool. I made a quick announcement about this, that we are finally being able to be viewing from the Mining-Pool stats.stream website. So stats are being presented over there. That's also a cool add-on, I'd say. But overall,
yeah, that's really cool that this kind of like little project. We are currently number 36th on like the world leaderboard for like pool hash rate. So I'm excited to hopefully we can get up even higher. I think we can, but that's really neat to see.
Maybe you guys talked about it last week or last meeting, but having public pool as like sort of a one-click install to Umbrel has been amazing. I totally like just got that running in no time, and I threw all my test miners at it. I think that's huge.
oh yeah, now that I added it to
Yeah, in the
Citadel.
future it's going to be
Yeah, sorry.
could be really interesting to see because in the future we won't really be able to see how many people are mining in public pool. I hope it's a lot, but until we start finding blocks, there really won't be a way to like estimate how widely it's used, especially if people start using it on Umbriel and Citadel, and that's exactly what we want. That's really cool. So.
Yeah, I've thought a lot about it. I mean, obviously it's your call, but like it would be on one hand exciting if all public pool instances sort of reported back sort of what their total hash rate is. But then, on the other hand, that's none of your business. So like it's kind of awesome to be able to just run this on your own and like no one will know about it and no one can do a damn thing about it.
Yeah, I thought about an opt-in flag you could change that would report those statistics, but if you do that, then you have to worry about like people misreporting, and then if they're doing that, or you're not capturing all reports, it kind of throws the whole thing off anyway, right? So I feel like it's kind of like an all or nothing situation. So I just said nah, and we'll let people be sneaky, and maybe someday on mempool, someone will just be like, oh look, that block was mined by public pool. So we'll see.
Yeah, I was talking about this with someone the other day, and it's like, how will we know when home miners take over? And it's like, we'll know because you'll see way less blocks or slightly less blocks mined by Foundry and Antpool, and things will start to look a little bit less grim on that pie chart on mempool.space.
By the way, while we're speaking about
Yeah,
this,
I think we're going to see a really big growth after the halving. I think it's going to crush a lot of the big miners who are just kind of holding on right now. Getting their income cut in half is probably not something that all of them are prepared for.
That's actually an interesting question from Agent P. Because Public Pool gets to put what's in the Coinbase, or at least part of what's in the Coinbase, for all blocks solved. So are we going to know when Public Pool or any of the instances of Public Pool submit a block?
Yeah, it'll be visible on mempool, assuming they actually add the tag. So each Coinbase has like a little public pool tag that adds to the extra data. So if there's a block that's mined by public pool and they haven't changed the code, we'll be able to see it
Soon.
oh yeah, definitely.
Any day
Definitely
now.
soon. We do have so many people on public pool nowadays, and it will just be increasing. The number of people that are getting onto public pool is increasing so enormously. Like I'm not sure, like on.
Yeah, I estimate with these new changes, I think there's still more stuff I can do to make it perform even better. But at least with these new changes I'm seeing, I think we can probably support 100,000 users, which is pretty crazy to think about.
Aren't we already up
We'll
to
see.
53,000 users or something like this?
No, currently most I've seen is around 23,000. Most of them being nerd miners.
All right, let's see.
Yes. Ben has done. We've mined several Public Pool testnet blocks, right?
That's correct. Yeah, I would like to. I was actually looking at that like 2 days ago. I got to reach out to the mempool.space team and see what it takes to add another pool in there, because you can search like all the blocks by which pool mined it. Like you can see CK and stuff. So I seem to get my tag added so that they can query it up.
There's going to be a lot of rows returned when they query that soon.
All right, I think.
Not yet, soon.
I think that's some sort of wrap up this session for today. I think we have covered a couple of topics today. So I think today's town hall was pretty interesting. We had darn good questions. We had a darn good couple of amounts of questions here. So I don't have anything else on my list for today. If you guys do have any other topics that you want to talk about. otherwise, I think we can change, or we can end the session here today, and see you guys in 2 weeks again.
Sounds good. Thanks everyone for coming out. It's been a good one.
There's one last thing that
Oh.
we need to mention. So we do have a little meetup in the next week, or not next week, but in 10 days. We will meet up in Germany, in Munich, to be specific, in the last week of February, from Monday till Thursday. So from the, 26th to 29th of February, we will be in Munich. Scott will also be there. So if some of you guys are willing to come over, meet us there. We are gonna go crazy there.
Yeah, come have a beer with us in Munich week after next.
All right. Sounds awesome. All right. Thank you guys for being here. Thank you, everybody of you who are listening, who are joining in here today, for being here. And see you guys soon in 2 weeks.